Before we dive into our session on aviation, I'm going to go over a brief biography of Daniel Bernoulli, who we'll be referring to in the episode. Daniel Bernoulli was born in the Netherlands into a family of accomplished mathematicians. Today we talk about Bernoulli's principle, which is how we explain how birds fly and how airplanes fly. So let's talk a little bit about that in this pre-episode. His father was a well-respected mathematics professor, as was his uncle. The Bernoulli dynasty is an amazingly big dynasty when it comes to the history of math. Interestingly enough, however, his father didn't want him to study mathematics because there wasn't much money in it. His father tried to get Daniel to study business, but he wanted to study mathematics. As a compromise, they agreed that he would study medicine and that his father would privately teach him mathematics. Daniel eventually got a degree in philosophy and logic, as well as a PhD in anatomy and botany, but he really loved mathematics. In fact, he got so good at it that his father felt threatened by him, which led to a very bad relationship between them. Fathers, let's not fight with our children if they're doing better than us in math. That would be appreciated. Thank you. He traveled to Russia to be a math professor. Even though he got to work with a good friend, who you will learn about in the next lesson, his good friend is Leonhard Euler. Even though he got to work with a good friend while he was there, he wasn't happy. So he eventually moved back to Switzerland, where he was a professor at the same university in which his father taught. He contributed a lot to our knowledge of mathematics, but what he's best known for is his work with fluids. Now, when you hear the word fluid, you probably think about liquids, but from a scientific point of view, anything that doesn't have a definite shape and can be easily influenced by pressure is a fluid. Clearly, liquids are fluids, but so are gases. Let's perform in this book, which is called Science in the Age of Reason by J. Wiles. They actually give you an experiment to perform there. The book goes on to talk a little bit about a natural philosopher. That's what they used to call scientists back in the day. There was a natural philosopher by the name of Gottfried Leibniz, who had discovered what we now call the law of energy conservation, which states that energy cannot be created nor destroyed. It can only change form. Bernoulli realized that any fluid, including air, must use energy in order to produce pressure. However, it must also use energy in order to travel. If a fluid increases the speed it uses to travel, it must use energy to do that. Well, since it also uses energy to produce pressure, increasing its speed will cause it to have less energy to produce pressure. As a result, a fast-moving fluid cannot exert as much pressure as a fluid that moves more slowly. We're going to draw a quick picture here and then discuss more. This idea, the Bernoulli effect, the fact that a fast-moving fluid cannot exert as much pressure as a slow-moving fluid is called the Bernoulli effect. So, Bernoulli effect is put in honor of Daniel Bernoulli. This is very common in the history of math and science, where you hear the name of something because of the founder, right? Faraday cage, right? We talk about Ohm's law or Ampere's law. There's names that are tied to specific people that were trying to figure out something at the specific time they lived, right? That's how our students need to understand the history of math and science. So, Bernoulli's effect, it actually governs a wide range of processes that occur in nature, and human engineers use it to their advantage all the time. So, let's draw a picture here. So, if you have this diagram, okay, we have a diagram here, and we have air moving quickly, okay, and we have air moving slowly, and there's pressure, high pressure here. So there's high pressure here because of the air moving slowly. And there's low pressure here because of the air moving quickly. So Bernoulli's effect is responsible for why airplanes and birds fly. You might have already learned this, but the wing on an airplane is designed so that as it moves, air travels more quickly above the wing than below it. As shown in the drawing on the left, this causes an imbalance in pressure. The air below the wing exerts more pressure than the air above it. The result is that the air pushes up on the wing harder than air presses down on the wing, causing a net push upwards. That lifts the airplane off the ground. Now, there are other things at work. I have heard some, lectures from like another professor where there's pieces of this that we can try to dissect further. Oh, by the way, I forgot to draw like air going below here, slowly. So we have the air coming below. We have air above it. We have, again, people that might say, let's go more in depth into this or dissect it further. But this is the explanation provided at a basic level. Bernoulli's experiments with air also led him to understand exactly where the air pressure comes from. He understood that the tiny particles, atoms, and molecules that make up the air are in constant motion. That motion causes them to smash into anything that is in contact with the air. And that's what causes the pressure that air exerts on anything it touches. He went on to use this idea to explain Boyle's law, which was discovered by Robert Boyle more than 70 years beforehand. Now, Boyle's law says that the pressure and volume are inversely related. Boyle's law states that the smaller the volume of a gas, the more pressure it exerts. This made sense to Bernoulli. After all, imagine a large group of people walking around in a tiny room. They would run into each other a lot. If they're walking around in a large room, they wouldn't run into each other as often. In the same way, gas particles that are confined to a small volume would crash into anything inside that volume a lot more, and more often than if they are in a large volume. Here's the interesting thing. Before I mention that, I'll just end this section from the book. It says, we know that Bernoulli was exactly right. However, such ideas were not accepted at this time in history. It would take more than 100 years for natural philosophers to accept the fact that the atoms and molecules in a gas are in constant motion, and the motion produces the pressure they exert on whatever they touch. A couple of interesting things. Somebody could have an idea, propose it in a scientific community, and people might not agree with them at the moment. So they don't always see the fruit of their labor. Scientists do not always see the fruit of their labor. Sometimes they have to wait till long after the ideas have been put forth. There was a man about 100 years after, so let's go back and see Bernoulli's birthday here. So Bernoulli is from 1700 to 1782. About 100 years later, we actually got the kinetic theory of gases. And that came from, we have several key people in that. We have James Clerk Maxwell and then Ludwig Boltzmann. So 100 years later, we see the kinetic theory of gases. And even Boltzmann, his work was not accepted in some of the work that he did until another period of time, after he had left this earth, right? So there's something called Boltzmann's constant, there's Boltzmann's statistics. Boltzmann had provided some good explanations for the presence of atoms and things like that. And there was a lot of people that just did not believe in the work he was doing at the time. So I know that this part is divided into two. I've talked a little bit about Daniel Bernoulli. This is, in a co-op setting, you can watch and learn about a scientist or mathematician. And then in the second part of this series on aviation, you will learn about the inspirational piece of the Wright brothers and how they persevered and just learning about the airplane coming into being. So Daniel Bernoulli set the stage for us with some of the mathematics and the physics reasoning, and then we get the actual implementation of some of these principles in the inventions that came later on. So 150 years later, you can see some progress starting from when Bernoulli passed away till when we got good running airplanes. There's a lot more we can talk about, but today I just wanted to go over Daniel Bernoulli's life and then introduce you to some of the principle, Bernoulli effect. Let me know if you have any questions, but we're going to take 2 weeks now. As I said, 1 week focused on Daniel Bernoulli. I want you to share some of your thoughts on the Bernoulli effect. Maybe just write out your thoughts. How do airplanes fly? Why don't you discuss that as a group? And then I hope you enjoyed the next video, which will hopefully inspire you to be an inventor. Take care and have a blessed day.